So for my first period, where I forgot to do the second half of this fill in the blank notes, here we're going to go ahead and look at what happens in anaerobic conditions. So following glycolysis, because this happens in the cytoplasm of all cells, whether it's aerobic or anaerobic. So in aerobic or with oxygen, pyruvate will then go into the Krebs cycle and be fully oxidized into carbon dioxide, and we end up with a whole lot of electron carriers being reduced. Now, if you really think about the big picture of respiration, all of these reduced electron carriers will be oxidized down in the electron transport chain. So we really do need this to happen, because this NAD plus is like a requirement for glycolysis. So here, when I say oxidized to reduced, what I mean is we need to turn NADH, we need to oxidize this back to NAD plus, so we can use the NAD plus in glycolysis and then reduce it to NADH. So we can use the NAD plus when we oxidize pyruvate to make NADH. So we can use NAD plus in the Krebs cycle to reduce it to NADH. So if you run out of NAD plus, you run the risk of not being able to make any ATP. So over here, well, what happens though if we don't have the electron transport chain? Because if you remember, at the beginning of the electron transport chain, these electrons and hydrogens that we strip off of this NADH are what's going to enter into the electron transport chain, and this proton will get pumped up to the intermembrane space to establish that electrochemical gradient. So these electrons and protons will be used, leaving us with the oxidized form of this electron carrier that can go back to glycolysis or the Krebs cycle and become reduced again. However, if we are in anaerobic conditions and there is no oxygen to pull electrons down the electron transport chain, the cell or the organism still needs ATP. And if you see here, we do make 2 ATP in glycolysis. So at least temporarily, this organism will do what we call fermentation in order to continue glycolysis happening, because glycolysis needs NAD plus will be reduced to NADH during glycolysis. So in order to keep glycolysis going in anaerobic conditions, we need to make sure we don't ever run out of NAD plus. So therefore, here we can go to the fill in the blank section. In anaerobic conditions, the cell still needs NAD plus, so we need to oxidize NADH. So in bacteria and yeast, this leads to alcoholic fermentation. And in mammals, or in animals, I guess I could say animals here. In animals, we get lactic acid fermentation. I should also point out some bacteria as well will do lactic acid fermentation. But anyway, so we have 2 options. We have alcoholic fermentation and we have lactic acid fermentation. And so in lactic acid fermentation, what's going to happen is when we look at what was made in glycolysis, we have 2 ATPs, 2 pyruvates, and 2 NADH. Well, if right now the whole purpose is to make ATP for survival, because we're in anaerobic conditions and that's the only energy that's going to be being made, this pyruvate and this NADH is not being used for anything in this moment. So what we can do is we can take that pyruvate or pyruvic acid and we can actually reduce it. So we will take the electrons off of NAD plus, the electrons and the hydrogens, and we will actually add them to pyruvate, forming lactic acid. And so when we oxidize this electron carrier to NAD plus, we change pyruvate into lactic acid. Now, if you remember, pyruvate had 3 carbons. Well, lactic acid still has 3 carbons. So the cool thing is this lactic acid will eventually make its way to your liver, and your liver will turn it back into pyruvate. So when oxygen is available, it can hop right on into the oxidation of pyruvate, the Krebs cycle, and get all that potential energy from breaking down its bonds. So over in yeast, let's look at alcoholic fermentation. We also have pyruvate made after glycolysis. But in this chemical reaction, it's actually when we oxidize the electron carrier, NADH, back to NAD+, it produces ethanol and carbon dioxide. So ethanol has 2 carbons, actually. So this here is alcoholic fermentation. And the cool thing, this carbon dioxide, when you add like yeast to bread, the yeast are going through alcoholic fermentation. And yes, they produce alcohol, but the carbon dioxide gas that's produced is what causes the bread to rise. So when you bake the bread, the alcohol will evaporate, and that you don't get drunk eating bread. And then the pockets, like the empty air pockets you have when you cut open that bread, is from where carbon dioxide was stored. But when we look at the big picture here in anaerobic respiration, they both are, whether it's alcoholic or lactic acid, the main purpose is to take this NAD+, or to oxidize the electron carrier, to regenerate or recycle or make more NAD+, so it can be used in glycolysis to continue to make these ATP. Because if you run out of NAD+, you cannot finish glycolysis and you'll have 0 ATP, and then you won't survive. Hope this was helpful.